So that's LSH in general. Now, what I want to do is I want to talk about Simhash. And the Simhash is a particularly efficient variant of LSH. It's efficient because you don't store the hyperplanes. You don't store the hash tables. You generate everything. You store the hash tables. You don't store the hyperplanes. You generate the hyperplanes on the fly for each words in the documents. It has slightly worse error bounds than clean LSH, but it's not very far off. So the way LSH operates, the way Simhash operates is you take a document, tokenize it into different words, remove what you consider non-content portions, maybe stem the words, assign the weights to words. In the simplest case, the weights are just going to be frequencies, or you could use TF-IDF weights or something like that. Then, for each word, you're going to compute a B-bit hash code. So a little hash code, and here you would use something like Adler32 or MD5, this B is really the same as K. No, it's not quite. So you compute a binary hash for every one of the words, and then you do something strange with them. So you take each hash code for each word, take each digit separately, you convert zeros to -1s, and you add them up by columns. So you're going to get some sums, and then you're going to look at whether the final sum is positive or negative. And based on whether it's positive or negative, you're going to assign the final bit as either 0 or 1. So here's an example, and this example you have in the textbook as well, right? So say I have a document, tropical fish include fish found in blah, 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 blah. Right? That's the document. What I do is I lowercase it and assign weights to the words. Now in this case, weights are just frequencies, how many times the word occurred in the document. So tropical is 2 because you have tropical and tropical there. Okay. So then, for every word, I generate a hash code. Now this hash code, as I said, it's just your normal checksum, MD5 or something like that. In this case, for simplicity, I'm using 8-bit hash codes. And then what I'm going to do is I'm going to sum up each column. But before I sum up, I'm going to convert the zeros to -1s. Okay. So when I do that, I'm going to get something like that, right? So let's go through one example. I'm looking at the second column. The second column, the bit was 1 in the, for the word tropical. I multiplied by 2, so I get 2 here. Now these were zeros. They turn to -1s. And this one is 1, so I have +2, -3, +1. This is all one big 0. Okay. And I have more words. I have 2 times the fish, so this is -2. Environment, -3. Including has a positive bit, so I'm back to -2. Back to -3. -2, -3, -4, -5. So the cumulative sum of the bits in the second column is going to be -5. You do the same thing for every one of the columns in your hash code, and you're going to end up with 8 sums because I had 8-bit checksums. If you do it with 256-bit MD5 codes, you're going to end up with 256 sums. And then what you do at the very end is you look at whether the result is positive or not. If the result was positive, you set the final bit as 1. If the result was negative, you set the final bit as 0. And the result is going to be an 8-bit Simhash fingerprint for the entire document. Okay? So, go over it a couple of times. As I said, it's available. The example is in the book. If you are curious, try to relate this to LSH. They are identical. So what I talked about when I was describing LSH with the hyperplanes cutting the space, and this stuff, it's exactly the same thing.